So what I'm going to just talk about is what I probably is a good way of saying, you call it just external innovation, because it comes from sort of doing some of the things or thinking through. Al has done a lot more doing than I've done, and I've done a lot more thinking, I suppose, than doing. But trying to actually solve very similar problems. I do like cats. I do like space, and Anthony's web imagery makes me very happy. So over the last couple of years, I've been sort of revisiting externally the problem of how we solve these big nasty industry problems, and my take on it has taken a few years to come across and figure out. But basically, I've sort of started to um, looking at the past and looking to the future and how we bring those things together. So I will get started here. So I started looking back. I'm not nearly as an academic as Al is, but I do own this book, so at least I cracked it open to see how old it was. So in 1984, this is the state of the sort of computers in the architectural office. This book actually references some of the companies that might be in the room. uh, Save the graphics, dot matrix printers and so on. What you see here is a lot of the things we're doing today. We have written specs, we have thermal and heating load analysis, we have a program, we have occupancy planning, adjacency matrices. Um, and the reason to look at this is sort of when you really look at our industry, we've done a lot of the same things um, in computers repeatedly over the years, but we often just change the context. This is one of my favorite images I've found. So HOK back then with HOK Sport, now Populous, built Wembley Stadium. This was an internal construction administration tool that we found it did things that architects like, that you still will not find in a construction administration tool today. This was 1998. We had a Palm Pilot app to go out in the field to record voice memos and to do punch listing. So the technology has changed substantially, but fundamentally we're actually doing very similar things. And I think one of the things that when I looking back at these tools is we've actually lost some system thinking in that world. So if you look simultaneously what's happening in the industry, going back all the way back to the 80s, we have AES internal to SOM. Actually, Draft is another tool that was part of AES. I know Mark's in the room. He's a fan. HOK had our tools, Draw Vision. We had the early tools that became, sort of Revit at some point. We had the sort of AutoCAD ADT Winter. But what really struck me when doing this analysis and looking back this far is we lost a system view of things. And that's one of the things I really liked about Al's presentation, is looking at this big mess of information that has to be put together, analyzed. And when you build your own tools, you have the opportunity to do that. But when you look at the market today, that isn't really possible, given that the way the market is developing is slicing up individual pieces of value, as you might describe it from a venture capital perspective, and then building a tool around them. I think it's actually a good thing that we have more tools than not. Phil, in an earlier talk, said we should have a large or a small number of tools. I don't think that's the right way to go for an industry that has thousands of different perspectives on data. But at the same time, you lose that, and it's untenable when they don't talk to each other. Did you guys get the audio of this? I'm sorry. Should have tested this.
I don't think so. Not for me.
So I won't play it then. But basically, this is a 1981 television show about computers and architecture, illustrating how they're doing shadow studies at San Francisco using a piece of software. Just again illustrating this idea that we're doing a lot of the same things. We're just doing them differently in different tools. and that somehow the tool doing them differently in different tools somehow has changed the actual sort of problem we had. So if you look at the history that's sort of happened, and so since I've been in a role at HOK doing these things, um, how many people remember Paracloud and Gem? Design Script was there for a while. We have Generative Components, which still is around. We had explicit history. These are all great achievements and great innovations in the technology of the problem, but generally, when you look back at it, I think we've reinvented solving the same problems over again, but we haven't actually reinvented how we solve the core problem, which is making all these things work together. So, going back to the space theme, one of my favorite space movies is this 1979 movie, The Black Hole, where um, the crew is basically overtaken by the idea of this very compelling captain, um, and they basically become automatons and sort of continue doing the same thing every day, over and over again. And I generally think we're at a place where we've gotten really good at applying technology, um, to the same problems, but we don't address the core problem. And I'll say that again is just this idea that, um, we spend a lot of time on tools that do the same things over and over again. So what that leads to is a lot of things look the same and have looked the same, and so it's not surprising that we haven't really solved the problem. So we lose data at many steps. This is something you hear all the time. Some people are better at it than others if you have your own systems. We can't reuse knowledge often, because oftentimes our workflows are serial. Um, they're not something you can do simultaneously. And so I was looking at doing a sort of an example of this, and I looked at something like carbon today, which is a hot topic everybody wants to do, wants to get good at this process. And if you look at it around the industry, let's take something like this, where you have a data set in a tool like Revit, a data set in a tool like Rhino, and if you wanted to actually do a study while you are working, you have to do this sort of very convoluted step. There's many good tools to help you with this, but what you're stuck with is there's no way you could do this anything close than I do the work, I model it, I export it, I import it, I assign it, and then I repeat. And that process has to be done in serial because you can't do it simultaneously. So that to me is this, something that looks like, um, basically wasting a lot of effort continuously and not being able to re-leverage it. So I've made this analogy that it's akin to, you know, mining a hole, digging it up and throwing it down another hole. So every time we have a new product that does the same thing, we just repeat this cycle. So we're sort of at a plateau in this context, and we need to sort of take a new approach. So the logical approach is to steal good ideas from a lot of different places, and there's plenty of to steal from, which is good. So the first place you could look at is what the film and VFX industry has done with USD, which is to say you move the data outside. We have this data. Why don't we sort of build structures of how we might store that information externally? And so this has gotten me down the path of inventing terminology and names for things. So strange matter, space themed. It's the most stable form of matter in neutron stars. We think it's there. We've never obviously found it. But it's looking to solve this problem and doing it in such a way that is stealing the good ideas from USD, but also really, really old ideas. So Operation Vittles, or you might know it more succinctly as the Berlin Airlift from 1948 and 49. Basically, this was, when the Soviet Union walled off East Berlin, but the one thing that came out of this was something that's still in use today called EDI, which is electronic data exchange. It was this notion that to do all the logistics on this very complex thing, we had to have a system of communication that you could send information, understand if it's been received, and break it into pieces. And interesting enough, this standard is still used today. This is just this afternoon from um, Walmart's website. They use an idea like EDI to interact with all their suppliers. It's one of these examples, and it was brought up earlier today that there's a lot of big firms um, in the world, and a lot of the smaller firms aren't going to adapt technology. This is a perfect example where a very simple technology, instead of thinking about very complex data formats, they said, well, let's just standardize the container you put data in, and then we'll work through sending it around. And it's actually a very similar concept to email in all things, because one of the things you'll look around is if we're trying to solve a distributed data problem, we have only one really good example in our day-to-day lives of this. So email, invented in 1971, it said the way to solve a communication problem is to say, make a system that can communicate back and forth. Today you can put files in it, you can put messages, you can put machine readable information in it, and this is actually how EDI is often used, or has been used in the past. But the email itself is just the container and tells you the information about who sent it, what it is, and so forth. And so taking this idea, what you're left with is, oh, well, I should look at how we might, instead of inventing a new file format that reinvents geometry or reinvents how you store properties, just do something very simple that tries to solve this problem. Very similar what Elle was describing is I have a bunch of data that describes the same things, different representations, and that the simplest thing you need to do is say, well, if I allow this, we'll talk through a chair an example in a second. If I take that idea and I break it into pieces and say, well, what if there's a bunch of information that describes that? It doesn't have to be the same format. It could be geometry, so it could be price information, shipping, and I just allow that to be distributed and describing the same chair. Maybe that looks like the solution. This is very much stealing from how the web is built. It's not surprising I'm using email, which is a internet standard, and EDI, which is also. So it's really this idea that we separate out putting all these pieces of data together from the actual representation, and I'll walk through what that really means in just a second here. So what you sort of envision here is each one of these components I show in this little diagram are not a format of data, they're actually just a header in a container. So the idea that I can send a piece of energy information that describes a wall or an issue or time, just like you can send an email and the email doesn't care what goes inside of it, but the email header tells you how it got there, what it came from. And so when you sort of map that onto a very simple problem, I want to speed things up here. If you look at something like furniture, if you try to distribute this problem today, you sort of get stuck really quickly. So I have a super simple planning tool that helps me plan furniture. If I want to move this data between tools or two groups of people that have different scopes of work, really I'm stuck with one of two choices. I have to just stop using this data today, or I just have to live with copies. But there's a false fallacy here, because if we think, well, actually, what if I just broke this data into pieces and then made those well-defined pieces? I could do something like this. I could say, well, I have a chair. This is the conceptual thing, but it's got a style, location, geometry, and if I were to put that together in the second piece of software, so bring that in, reference it, I could make some new information that if I externalize the data into these standard pieces of information, I could get some duplicates. Sure, I got two chunks of geometry, but I could actually just decide, just like USD is doing, that you actually just decide which representations you care about, and you say, well, this is the chair I care about, outside of any one of the tools. And there was a conversation earlier today in the room about data sharing and stuff like that. To me, if we don't look at this as a base problem, so not the data itself, but how do we structure data in any format that you can actually solve a problem. And the problem I'm sort of pointing to here is this idea that, I have design information. I want to work with a CM that needs to procure things. I want to do it out of order. I want to do it non-serially so I can start sharing the information I have. And this is a problem we have today. Then if I break it into pieces that are well defined, very similar to some of the concepts that BOM has, but in a more generic way, actually, then the CM can go in and add their own data to describe that entity. And you could start to think about, well, this actually could be a CI/CD sort of approach, because these packets of information are self-describing. I'm cost data, I'm location information, and it doesn't require that you start with inventing a new format. You can have, location and information can come from how Revit defines location. Doesn't matter. You just have to choose a standard, but style could come from how, USD or Speckle does it. So the idea that you can assemble, and the word composition that Al used before, that makes this higher order thing from the pieces of data, I think is really, really important to make this successful. And then obviously, if you sort of go back and make some changes, the idea here is you could continue and update just the pieces as you need, and we have much more control and granularity in the information we need to show. I don't want to go on forever. I have a few more things. So these are all good ideas. I'll step through these slides. This is sort of illustrating how this would come together in the long term. Progress. So it's more than a good idea, but it's taking a while to develop, and it certainly takes time to gain momentum. So thus far, we've sort of mapped through this data structure. In the last couple months, I've been working with Building Smart to say, okay, this is not IFC or anything like that, and it is intentionally just a way of structuring information, but Building Smart wants to modernize IFC. So the idea that we're going to start putting a new version of IFC into the structure and start making a sort of entity component base. This is the sort of terminology you should look at when looking at this. So we're going to start doing that in the next couple months. But then at the same time, there's a sort of whole series of discussions from the Open Letter Group in the UK to big software companies that don't want to be locked out of an API-based workflow in the future that we're talking to. So you need two things. One is I've described strange matter, which is sort of the way you structure data, and then the bridge is a concept that comes out of the Open Letter Group's way of describing things, where you can put these things together. So I'll end it there by saying, help me make an email client for the future. So gross to say that, but like I said, email's the only distributed technology we have that really works. So thank you.